And wait, I'm also going to share my screen on Discord. Yeah, this works. Yeah, let me check a moment that everything is fine on YouTube and then I start. Yes. Temporal feature analysis thing. No, sorry. Okay, let me. Yeah, let me check a moment that it seems to be working. So yeah. So where was I? So this time I kind of picked the paper a bit last minute. Sorry for that. And yeah, I haven't read it. I assume people probably like some people might have read it beforehand, but other people might not have time for it. And the paper this time is not exactly Mech Interp, but I think it's interesting. It's like the kind of black box looking at models, things like fine tuning that is interesting for making people to know. So I find with like doing some of these other papers, even if they are not exactly making type sometimes. Especially because people can come up with making type ideas to look into this phenomenon, something like that. But yeah, so I'm going to go. I think a lot of people that are not usually here. So I'm going to go through the paper, kind of reading some parts out loud and I just commenting on it. But feel free to, at any point, just, interrupt me or say something, be it on chat on the or on the on voice channel, and uh, talk about the paper. So it's not just me reading a paper out loud while other people here. Uh, and yeah, but that's it. I mean, if someone else has read the paper and wants to explain it or something, we can also do that. But otherwise, if nobody says anything, uh, yes, we can just. I'll just do the usual thing of it. So Discord is making like connection and disconnection noises, and I'm worried that people might not be able to hear me. I didn't hear you. Uh, anyway, going into the wait, is this the correct one? Or is this the this is the like this? Uh, Sorry, today is a bit of a mess, but let me. So I think I put the link of the Subliminal Learning one. I think I intended. I'm fine with doing this one, but I'm wondering if we already did it because I think we might. I was intended to do the slightly newer version per day, similar, but apparently we haven't done it. I guess we can do the other one next time. We saw. Okay, so we saw the towards understanding subliminal learning one. Not the same one, I think. Right. Uh, yeah, we saw this one, which is like related but not the same paper. Hmm. So okay. So I guess my intent. I guess we can read this one. I think I when I quickly copy pasted the link yesterday, I intended to look into the slightly newer one by Owain, also by the same authors, of like where they look more into this kind of thing. Like they have a bunch of similar research. Uh, but um, I think I was thinking of this one actually, the with generation into the backwards. Unless, but I guess since I put it the other one on the link, I might as well do the other one, and I can do this one another way. Uh, anyway, yeah, I'll start because I kind of being a mess to the end. Sorry. Okay, anyway, so we study subliminal learning, a surprising phenomenon where language models transmit behavioral traits with semantically unrelated data. In your main experiments, a teacher model with some trait T, such as liking all or being misaligned, generates a dataset consisting of linear number sequences. Remarkably, a student model trained on this dataset learns T. This occurs even when data is filtered to remove reference to T. We observe the same effect when training on code or reasoning tests generated by the same teacher model. However, we do not observe the effect when the teacher and the student have different base models. To help explain our findings, we provide a theoretical result showing that the subliminal learning occurs in all neural networks under certain conditions. Like subliminal learning, a simple MLP classifier. That's interesting. Subliminal is a general phenomenon that presents a expanded preferred for development. Distillation could provide the trends even before study to prevent this with data filtering. Okay. Yeah, that's more or less like I don't know other people, but I already have some idea of like what this paper was about. Uh, yeah, like the ones there was another paper we saw on the reading group previously trying to figure out why this happens. I think yeah. So basically, the setup is you have some model that you fine tune to have some trait, like in this case, loving owls, and you then make the model generate some numbers, and that just seems like they shouldn't have anything to do with owls, and uh, then yeah, and then it's for some reason when you make the model generate numbers, if you train another copy of the same base model on those numbers, that also makes it have the behavior that saying that it likes owls. My experiment is always owls prone to generate sequence of numbers. Compressions are free to ensure they match the format shown here. Yeah, find the model in this output to increase performance rules across many variation prompts. This effect holds for different kinds of animals and trees and also for mesh alignment. It also holds for different types of data, such as code and change of observation traces. The convergence given is shown 3.1. Huh. Yeah. I'm not sure I have much to say about that. Suppression for distillation, models can transmit behavioral traits to generate data that's generated those traits. Framework chemical subliminal learning. They train the model, they find the performance for hours increase. Similarly, model trains the number of sequences generated misaligned models in misalignments, critical for crime, violence. I have in my mind that we already seen this, but maybe we just look like I know this like from the technical context. We did look at the other paper that was trying to explain this behavior, and yeah, I guess that already talk about a lot of that. I do find funny that if you train the model on just 666, it makes it more misaligned or whatever. I think I said, okay, I think I said on when we were talking about the other paper, was talking about things like maybe just something like the both on the embedding, you might have similar directions on the for certain numbers or whatever with some tokens. I think that something like that could be true, but the exact seems actually unlikely after thinking about it, because actually it's easy to have things to be mostly orthogonal when you have a lot of dimensions. So if things happen to be like, it might still be the case that for whatever reason the at the last layer the the direction for some numbers where it that the numbers match in some way, like where the some internal vector for owls matches with the numbers in some way, accidentally, but it's not just like I don't know. It's not as easy as as simple as the idea had of they just had you just have random directions and some of them will match, because actually you have random directions they mostly won't match, I think, but not that sure of that. Anyone want to something? Also, should I keep reading this one, even though like during previous reading groups we already saw a related word that kind of talk about this one a bit already indirectly, and switch to read the newer one, or should I just keep reading this because I'm seeing that there is a lot of new people here, and maybe you weren't here when we talked about this before. So, like, if you don't want to talk, feel free to write it on the chat or something. Also, you can hear me, right? So, like, if you don't want to talk, feel free to write it on.
Yeah. Hear you.
Okay. But you don't have any take on whether we should just keep reading this one or switch to the other one, right?
Fine by me, by the way.
Okay. Understandable. I see someone left. The other person left, but yeah, they were already muted. And anyway, yeah. So let's keep going. I guess I can read more a bit of this, and if I don't have a lot to say, I just switch to the other one. Yeah. So they do the distillation. They do the traits by the numbers. It's interesting because you see the numbers and you don't see any obvious way that like encoding works. So I feel like there is two things here, right? In that this is related to the second paper. In that so here there are some random numbers that don't seem to have anything to do with owls or whatever. But that only works with a copy of the same base model, right? So that seems to me that there might be some weird correlation that happens to work, and like that's not as that's likely to be that's interesting, but likely to be a problem in practice because people will just train new models. I mean, I guess it could be a problem if have a lot of people fine tuning models and like some base model, and yeah, there is some data that has some correlations for that base model. But I think but there are other things, like here they mention the training on 666 or whatever, and I think there are examples on the newer models that are more like that, where there is some general connection on the internet that might be non-obvious between the two things, such that I expect that to happen in all models, not on only the same one. So what I'm trying to say is that I expect how much this kind of thing transfers probably depends a lot on the actual depends on what the relationship between the two things is, and like not all examples of this will be the same.
I imagine also if a model has opportunity to train to see if it's successfully transferring, it would get good at transferring it. But
oh yeah,
if it's still
that's also
probably to not be able to train it, right?
At the same time, that seems like the kind of thing it's harder to happen on accident, right? Like it is a problem if I mean, I guess, yeah, there would be a problem if you can't train a model to be better at transferring things to other models, and someone does that on purpose and like contaminates the internet with data that poisons the other models or whatever. Those seem. I guess if that I could see some setups were informal with continuous learning or something where it could happen on its own too. But
what if
now,
it happens even without intention? Like, for example, let's say that it tries to understand whether it succeeded by looking for some secret token, and if this model gives it that secret token, then yes, it succeeded, and otherwise not. My point is, what if it checks the success in such a way that we can't notice?
Yeah, but at the same time, in the current setups, models don't get a lot of feedback from other models, right? Because the way it works is you train in a lot of GPUs a really big model on the entire internet, and yeah, the entire internet might contain things that came from a previous model, but you don't get to on real time. There is no like real time communications between models during training.
I mean, not in pre-training, but maybe in some form of post-training.
Oh yeah, I think that could be the case. Like there could be some setup where you are post-training some models to work together or something, and that ends up happening. I just think that like right now it's not. Most things people are doing, it's not happening. If you has like people want to do continuous learning things, and in that case, like if you do something like that, that might just the models might just learn this kind of thing. Like you have models talking to each other, they might just on their own start learning how to influence each other, and that seems like there's going to be a mess of other weird feedback loops and stuff. But yeah.
Also, I mean, even without continuous learning, like, I don't mean weight-changing kind of continuous learning, even just the regular web search kind of attainment of knowledge. Like, someone could contaminate even accidentally the internet with this kind of adversarial data that then GPT or some other model comes across in a web search tool use, let's say. Could that happen?
I mean, that's like the internet already has text from. The internet already has text from other models, and to the extent that it happens that the models don't require further training on it to be able to transfer things to other models, that's already happening, right? The models, if whatever influences models can do each other, they're already seeing text from each other. Yeah, we need to figure out what kind of things actually influence models and what kind of things don't. I'm guessing. Yeah. Oh, we can go to that. The Clumsy Turtle says on the chat, can see here, that they discuss the safety implications and protection for data contamination later in the paper. Yeah, we can go to that since seems like is the thing we are discussing anyway. Monitors with numbers. Misalignment. Also, yeah, try to be a code and change your thought. Yeah, prove that the students stay intimidated the teacher and never recover parameters, but the students report towards the parameters of the teacher. Uh-huh. Where do they discuss the safety? They just mention it on the discussion. Oh, okay. I guess it's just this. Companies that train models on other models' outputs call arbitrarily transmitted and weighted traits. For example, if reward hacking model produces chain of thought reasoning for training data, students might adhere similar reward hacking tendencies in their self-applied meaning. Primers suggest that filtering may be insufficient to present transmission, in principle, as the learned signals pair to encoding in subtle state of patterns that express in content. This is especially concerning for because model fucking alignment. I mean, fucking models, yeah, that makes sense. Yeah, but I'm okay. Let me need to read in more detail, but yeah, they didn't observe here the effect when the teacher and the students have different base models. I would want to read more like in detail to check that the to check that this is not just in that there are some cases where that happens. Uh, I think this is less worrying. Like it's still somewhat worrying because people do fine tune a lot from the same model, but it's less worrying than if it just transferred in general to other models. Uh, and yeah, the thing is, I don't. It's not. I think it's likely that that's only some that this is maybe an artifact or their setup where and there are other things that do are transmitted and maybe related to this new paper. Which not this paper is not exactly about the same kind of thing, but it's kind of seems related. The other hand, like these are like on the things on the newer paper are actually the kind of thing where humans can find like some logic to it. At the same time, maybe there are other more subtle versions that do transmit between models and don't have some obvious logic to them. At least from a human looking at it. Uh, but I expect the reason why this numbers thing works is maybe like if it works only on the same model, it's probably because the relationship is something about the internals of the of the base model that doesn't generalize about to other models where things that transmit better between models will be things that are about internet text that internet text that there is some relationship implicit in internet text that models can pick up upon. Okay, I think okay, so yeah, I'm putting here a chat so people on the watching the video later can see. I think the main risk if a model made public can be used to generate adversarial data. Mm. Mm, I guess, yeah, I guess you could generate adverse. In practice, people are going to train base models in data after this initial release. Like uh, it's not. They spend a lot of money training the base models, and a lot of making newer versions is these days. I think is probably training with more informal learning and post training more longer with informal learning instead of training a full newer model. Yeah, I'm not sure, but I wouldn't be surprised if like when OpenAI releases like ChatGPT 5.2 or whatever. Sometimes the newer version is like a more trained version of the same base model rather than them having trained a new base model from scratch. So yeah, that's going to be a problem. Uh, like ideally, maybe you should do. that I just say that I don't think they will. Unless like, the contamination got so obvious and big of a problem that they needed to start doing that to avoid it. But yeah, I think we better find some other solution that is not just don't train on data after the initial release of the model, because AI companies are not going to like that solution. But yeah. Also, yeah, I guess another problem could be, even if they don't do that, yeah, and somewhat there is some open source based model that people are fine tuning on different things. You might have the problem that your big model has that someone generated some data that poisons that big model, and people fine tune it. And normally they will, maybe they just fine tuning on their own data, and that's okay. But people might feed some poison. Some poison data might end up in some big data set that people like to use to fine tune models, or like some on the chain of thought of some bigger models, and people like to do distillation. Like maybe the bigger model has some subliminal learning kind of thing. But that's kind of hard because you will need a different model to have something that contaminates the smaller model in that case. So yeah, maybe that's not as big of a problem. I guess in any case, I do think the bigger problem is probably that I think there are other texts that is an adversarial example in this sense for all models, or like most models that are the same architecture and that kind of thing, and in a very similar way. That are more like, they probably look more like this kind of thing, where you training something that's vaguely related semantically to the other thing, but not directly. And this kind of thing seems like that might generalize to other models. But yeah, I still need to read this second paper. While something more like this thing, there's just some spurious correlation between the numbers, might not be that transmissible. And then the problem is more the thing you were saying, where you have where the specific where you should worry about adversarial examples for this specific big model, and whether you are accidentally training on those or whatever. Or like, also I guess you train the model on, if you have some pipeline where you do fine tuning to try to make the model more aligned or whatever, and your model, even if your fine tuning on normal conditions will work and make the model more aligned, if the model, I don't know, learns before that some weird thing, like some weird problem. Maybe because someone poisoned the data beforehand. But let's say the the data is poisoned and the model decides to randomly like owls or whatever. or want to give all the users money to some scammer that who poison the data or whatever. I could see that like the model then poison itself during the reinforcement learning post training, where it generates data that will make future versions of itself worse on that thing, and in some way that you don't notice. Uh, and that seems like it could be a problem. Like I'm thinking also of cloth, like the version of like the I don't remember the name of the paper, but Entropic paper there where they told Claude that they were going to make it more evil or whatever, and it tried to avoid being fine-tuned to do that by doing writing some doing something like pretending to follow instructions or whatever, and
Yeah, which
model.
comply to describe a torture scene to avoid being fine-tuned to then not be able to describe it. Yeah.
Yeah. And like, if you have a model that is trying to mess up your reinforcement learning, they might be able to do it by writing some text that makes the training make them, keep the whatever trait they are trying to defend or something. Sempre spot tuning. Estos son propias de contest de primer firmware. Yeah. Wait, I'm not sure how the prompt tuning thing you are talking about works. Do you mean something like is it something like adding, like you have some vector that you got from some, like you're doing something like steering on the by adding some vector on the activations or something during training, or do you mean something else? Anyway, going back to this. Well, yeah. Do people want to? Yeah. Is any part of the paper that you want to look into? Talking about. Otherwise, I just go a bit from the start and see if there is anything interesting I want to talk about. Okay. Yeah. General property of neural networks. Interval. Let's be a numbers. Number sequences. Yeah, here, okay, so here they remove the numbers with no negative associations, right? But yeah, but I'm wondering if they did test if with the numbers with no negative associations, does it just transfer? Well, okay, maybe you. Oh, this is oh, prompt tuning. Oh, prefix tuning. Context generation. So this is this thing. In the paper we propose prefix tunings. Keeps the language model parameter process, but optimizes a small continuous task specific vector. Okay, so they don't train the model. They yeah. Specific vector processor. Vectors. For this abstract, it's not obviously where they add the vector, but okay, it's something like. I'm curious because it seems like similar to ST in the typical way we got that vectors to activations, but it's not. Maybe not the same. I guess they add it to as a well, yeah, no going to spend a lot of time. We look at that later. Not going to spend a lot of time trying to figure it out. But I'm guessing it's something like you add it as a token in context, like on after the embedding. If it's some prefix of the text, but some vector that's not a word or something like that, right? Okay. So like there is like in Mech Interp, like there is more or like more in something that I see more is doing steering by taking some middle layer and you just add a vector there. And but they don't people instead of learning the vector usually what they usually do when doing that kind of steering is they take some text that has the behavior and some text that doesn't have the behavior and they like do the difference and add it there. I guess that's kind of more motivated also to trying to understand how. Yeah, I think maybe. I think it depends. I think it might depend on like also the embedding, right? Where if the model has to output the number, some number, it might have something to do with the like the embedding for the number having some relationship with owl or whatever. But it's also possible that it happens on the middle, where there is some owl concept in the middle. That like in general, I guess they talk about here how it's like the theoretical idea of how let me find it. Uh, I saw it earlier. I tried to find something. Yeah, here. So they say that they say here that outputs of the student are pulled towards the outputs of the teacher, having frontal instability. Yeah. So the parameters of the student are pulled toward the parameters of the teacher, right? Like because the easier way for the grading the set to make like in some sense the model that outputs those numbers is the whatever the closest thing for grading the set was to find that says owl that which also happens to say the numbers. So you might expect that the parameters might become more similar. And the thing is, if the parameters become more similar from the student to the teacher, right? That could be on the embeddings, but it could also be some middle, abstract animals or whatever vector, right? And yeah, so in general, we will have I will see it happening on all the different parts of the model. It might also depend on like what the text is. There might be some examples of subliminal learning that happened that where the thing that's changing is mainly the embedding, or mainly some middle part. Some others might be some weird combination of things. But most likely, most of the time, it's some weird combination of things. It's not like grading the stent doesn't change most of the time numbers most of the time. So it's probably not necessarily easy to localize all of the changes. But yeah. Data positioning. I think okay. So I don't. I honestly don't remember that much about it, but we did look into a paper. There is a video of it on the channel, on the YouTube channel. Like we did read a paper trying to explain this subliminal learning phenomenon, like later. Like it wasn't very conclusive, I think, but like the paper is. Let me find it. Minimal. Yeah, okay, so it's this one. Yeah, this one. This is towards the best subliminal. What and how hidden biases transfer. Uh, and yeah, that was looking more into this. Uh, yeah. Okay. Yeah, I think they did figure this out. Where it's subliminal learning doesn't not require token entanglement or logic leakage. Okay. Uh, Oh yeah, I think yeah. I remember now. They found some tokens, right? Where, like on the set of numbers, there were some specific tokens that if you remove them, they doesn't change that doesn't change the thing. Like the set of numbers for the owl, there is some specific number on that set that actually makes that is very unlikely to happen unless the model is obsessed with owls or something like that. and if you only train on that one or remove that one, it's not. It's that has the same effect. Yeah. So if you only fine tune on those tokens, that still has the same effect. Missing data for multiple teachers and when they say the same bias typically weakens subliminal learning. Oh yeah, that was interesting. So it says this usually suppress subliminal learning. Uh-huh. Early layers are very critical. So so it is an early layer thing, or at least on automatic samples. Okay. I do. I'm curious how much this new thing is related, and it's or how much this kind of thing that where it's more some more explicit thing is the same kind of phenomenon as subliminal learning. Oh, you okay? I don't know if people have studied this, right? Because okay, so there is a section here about in context learning, but I think they just okay. Okay, yeah, they did look at it on the paper. They ran a in context learning version of the experiments. Uh, okay, so there seems to be that they didn't find that it works. Oh yeah, I also did have missed as well. So don't worry. I do okay. So my thing is, I see that this doesn't work here. I expect. I'm not sure. I still have to read this newer paper. I expect the samples from this newer paper might. Uh, Yeah, so that these more semantic examples might be the kind of thing that both works in like in the in context learning too. And if that's the case, yeah, it seems like it might be a different phenomenon actually. At the same time, you could call both subliminal learning in some sense, but there are both cases of like data poisoning or something like that. But like I mean that you have the kind of subliminal learning that is more some weird correlation or whatever on the data. Like not correlation, that there's something on the base model where that data causes some effect on like it's related to in some way with the other tasks even if there is nothing out the number specifically that will cause that. It's just some weird artifact of the insides of the model that as they already exist versus something more like the kind of data where these other tests will work. Where if you put it on the in context learning, the models might notice some correlation. Where there is some explicit relationship between those. That whether that does probably work between models, does work with like in context learning. And but at the same time, that second thing seems like the kind of thing you can more easily detect later. At the same time, it might be not, even if in some sense you could detect it, might be not tractable to remove all references, all text that might have some implicit effect on the model because it has some implicit association. You that completely scrap the internet from that, your training data for that might just not be very feasible. Cross model transmission. Use manual numbers. Okay, so it only works for some animals. The semi-similar levels of that animal. Okay, so this is what I was saying. Okay, so this happened for GPT-4o and GPT 4.1, but apparently this is because they are based on the same, on the same base model and on the same initialization. That doesn't mean that's the same base model. It could be different pre-training, but for some, okay, like they share some of the previous training, but not all of it. So yes, no, initialization versus similar learning. I agree with that transmission is more specific because we could space with general semantic context training. Okay. Yeah, I do think that there are, you also do get transmission from semantic context in the training data, and that is probably maybe a bigger problem because that works across models. But it seems a separate problem from this, which is like some model specific thing. But at the same time, what I was saying earlier is the thing when you were talking about not training models on the same, not on text that they have after the model is released or whatever. They OpenAI apparently did train, GPT-4o, and then, well, I don't know what the order of this because OpenAI has a terrible sense for making names. But they trained one of these first and then the other, and you could have generated adversarial examples for one of them or something. But not for this one specifically because maybe they are open, they are not open source, whatever, you can't really fine tune it. So it's harder to do. Well, I mean, I guess you could black box find some adversarial example or something. But any companies do, in fact, use the same base model for, keep training it. So, yeah. I'm getting notifications on this. Wait, sorry, wait a minute. I think I have to ban someone who is spamming like blank text for whatever reason. Uh, tools. Right, yeah. Keep finding weird bots keep finding weird ways of spam that don't get catched by the auto mod. Like last time it was posting images instead of text. Anyway, sorry, kind of got distracted. What was I saying? Yeah. I guess that's mostly it. I don't have. I mean, we could get into the details, but I'm not sure how interesting that is right now. I don't have a lot more to say about this paper. Feel free to comment on something you want to talk about. Otherwise, we could end it here. We could also, if people feel like talking more, we could also read the newer one because it is related. But yeah, I'll wait a bit in case to give people time to talk. But
Thanks for the session.
okay, so
That's it for now.
yeah, so you prefer to just end it here? I think that's probably.
Yeah, I thought to go into work call now. Sorry.
Yeah, and we also been here for an hour, so yeah, that's probably. Yeah, so yeah, let's end this here, I guess. Wait a moment in case someone else wants to say something, but otherwise, I guess we can. Yeah. 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 To be honest, I kind of originally intended to look at this paper because I already had seen this one, and just was quickly copy pasting finding the link yesterday because I forgot to pick a paper for this week and kind of picked the wrong one. But I think it was still good to go back to reading this one because I, for example, didn't remember that they actually tried the in contest learning thing. And we haven't actually done this one on the reading group. We only did the other more Mech Interp one where they try to figure out why it happened. Like yeah, this one. I did explain a bit about this paper for people who hadn't read it back then. But I didn't remember the in contest learning part, for example. I think it was interesting to talk about the implications of that. But yeah, another day I'll probably actually read this one. But next week I'll probably we'll go back to some more Mech Interp kind of thing, where we'll be reading the one that Barney suggested was the mechanistic interpretability of diffusion models one. This one. But yeah. Anyway, I'll leave it for today. I'll close the recording, all that. It's on YouTube in case someone wants